Okay, so I am honored to introduce one of my good friends, someone I have researched with, someone who has put a lot of effort into this community. Mattia, I have to say thank you, honestly. You do so much and give back so much, and you love what you do, and it's amazing. The
Thank
class poster for 585, the entire backside, that brilliant list of all these artifacts, Mattia, thank you for doing all of that. He is an author of that. He teaches 585, which is my smartphone class. He's brilliant. I've been honored to co-teach with him, and co-teaching with you is like no other. If you ever get a class where both of us are teaching together, it's a lot of fun. Um, Mattia's efforts and how much he knows on smartphone forensics and iOS and computer forensics in general is astounding. And this talk is so important. Most people don't think about when you hold your phones and you're interacting with these devices, what can go wrong if you misstep or you take something out of the proper order. So thank you, Mattia Epifani, for doing Order of Volatility in Modern Smartphone Forensics.
thank you very much, Heather. I'm also honored to be here. And thank you for your words. And a great introduction. There's nothing that I can add. I just want to add that I'm from Italy, and I have various roles, but I'm a science instructor in the 4585 and 4500 class. As Heather said, the topic of this presentation is, it seems like a pretty old concept. And in fact, since February 2002, at least, the famous RFC 3227 introduced the concept of order of volatility. And we have worked in computer forensics for years with this concept in mind. When you have to approach to a turned-on computer, or in general to a turned-on device, you should proceed from the most volatile to the less volatile information. And the RFC 3227 was developed and was written in 2002. So when most of our activities were on computers. And so, as you can see, the examples are registers, cache, routing table, ARP cache, temporary file systems, and so on, and up to archival media. So the less volatile is archival media. But the concept is, how do we approach the correct order of volatility when we have to deal with modern smartphone? In general, we can, and of course, this is part of the acquisition. So this is part of the identification, preservation, and acquisition steps on a mobile device. There are some key and general questions that we should start when we need to start our work. And the first one is, of course, if the device is turned on or off. And this is the same when you have to approach to a computer. Is the computer turned on or off? When it's turned on, in a computer, you can decide typically to, if you have the right privileges, to execute commands up to acquiring the entire RAM of the computer, for example, or in general, execute applications or trusted applications or command to try extracting the information that you will lose if the computer will be turned off. We need then to think if we can have a similar approach when we have to deal with smartphone. The main difference is that with smartphones, you typically are not root of the device. So you do not have the right privileges, and also it's quite complicated to extract the entire RAM of the device. There are, of course, projects on that, but this is something that is difficult to apply in real life. In real cases, when you have, when you are, like, for example, in law enforcement, and you need to act on a device properly and promptly before this information is lost, definitely. And if the device is turned on, one of the other key questions that we typically need to check if the device is locked or unlocked, or if it is locked, if we have access to the device. So you can get access to the operating system and all the application in terms of interacting with the device. If you are in the situation of a turned off device, well, we have a lot of different solutions, and I don't want to spend time on that because we will have something in the next panel with Heather and the others. Acquisition is a key point. Typically, we want to extract a physical image or a full file system. But the question is, sometimes, also when you have a turned off device, you do not have an approach that allows you to extract either a full file system or a physical acquisition of the device. And then you have to rely on different methods. And this means that sometimes you need to turn on the device, you need to interact with the device to activate some specific features like USB debugging. You have to pair your device with your forensic workstation. And so in this case, either if the device is, especially if the device is turned on, you should approach in a way that acquires the data from the most volatile to the less volatile, by having in mind that you typically are not root. So you need to use as much as possible of your tools to extract as much information as possible before they are lost forever. When it comes, for example, to Android devices, when we cannot create a physical or a full file system image of a device, we typically rely on different techniques. Some tools install an agent, and this agent allows to extract, for example, data from content providers like call logs, address book calendars, and stuff like that, and maybe taking screenshots of the device and perhaps convert the chat to a text file. So various features introduced by various tools. We also rely on backup features. We can use the native ADB command. I'll be back to it in a few seconds. And also you can use vendor-based backup, like for example, Huawei iSuite, Samsung Smart Switch, LG, and so on and so forth. And last, we can also use other techniques like, for example, APK, application downgrade. Also in this case, the question is this the best acquisition? Can we get more? So is there any other information that we can get from the device that cannot be extracted with the typical methods used by either commercial or also open source tools? And the second question is, what's the correct order? How do we start, and which are the most important commands to run first, actions to be done and commands to be run first? In this case, our friend is the command line tool called ADB. I'm not telling you any secret. I'm just proposing you to read the developer.android.com website, just pointing you to some specific pages, because those pages that were meant to be a repository for Android developers are also really, really useful for us. Because they allows you to understand some services and how the Android operating system works. We all know that it's based on Linux, but we also know that it's a variant of Linux. And what I strongly suggest is to read the references I'm pointing you in this presentation, because this will allow you to understand how you can leverage these native tools, not only ADB, but mainly ADB, to extract as much data as possible. Of course, to interact with a device through ADB, you need to activate USB debugging. So it means that you need to have access to the device and being able to activate it. Once you have the command activated, and of course, ADB can be easily downloaded from the Android.com website for Windows, Mac, and Linux. And this is a native tool. It's just like a few megabytes, but this is really, really powerful in terms of what you can get. As you know, as you probably know, with ADB, you can open a shell. You can open a shell on the device. If you have USB debugging activated and you have paired your device with your workstation, you can open a shell. This shell will allow you to write commands, to give commands to your device. And all these commands are available on your device. The main problem, as you all know, is that this shell is not a root shell. So you cannot get access to the entire file system. And especially you cannot get access to the data folder where most of your data resides. But still, there are a lot of things, a lot of commands that you can run from an ADB shell that are really useful can be really useful for your investigation. We can categorize command types in different groups. Getprop, Linux, Dumpsys, package manager, backup, and pulling files. I'm going to go through all of these quickly. I have a huge presentation, but I'm going to go quite quickly, and you have all the references. The first one is getprop. Getprop is a command that you can use from the ADB shell to read device properties. These device properties are not changing typically, so this is not really relevant in terms of order of volatility, but you can get a lot of information about your device. You can get the device model, manufacturer, the serial number, which version of Android is installed, which security patch is installed, the specific time zone, the build ID, the product code, the chip name that is really useful, for example, to understand if there is a technique based, let's say, for example, on a specific chipset, either Qualcomm or Exynos or MTK or whatever it is. Also, you can get the encryption state. You can see if your device, if the device you need to acquire is implementing a file-based encryption or a full disk encryption. And that's another important point that is relevant when you are dealing with a turned-on device. You know that with a file-based encryption, keeping the device on is a key point. The second categories are Linux commands. Linux commands are, as you know, Linux. So I listed some of them. You can add any Linux command that is on Android, and you think it can be useful for your investigation. You can get the Linux version. You can get the system time and uptime since when the device is up, so when it was probably last booted. You can get the IP address. This is a really volatile information. If you disconnect the device from the network, you're going to lose this information. You can get the list of active network connection. This is actually, as we know, an information that will be dropped, will be canceled, deleted, lost if you turn off your device. The commonly used netstat.an is a kind of command that you can also run on a Linux device. And here you can see, for example, the list of IP address that your device is connected to, and maybe it can be useful also for malware investigation, for example, but also for understanding which servers, which services the user is using on the specific device. Also, launching, executing PS can be helpful. For example, in these slides, you can see a case in which you have a turned-on device, the Tor browser is running, and is running now because the device is turned on. To check it, you should go through all the processes manually, all the tabs manually, and check if there is an instance of Tor browser, for example, running at that time. In this case, you can get the list of processes and maybe then check, oh, I'm not going to close that process because we know that Tor browser is not storing data on the NAND memory of the device, but only in RAM. You can get the list of services running. This is one of the key points and one of the most important points in my concept, in what I want to transmit you with this presentation. The command service list will provide you the list of all running services on a device. The number of running services strongly depends on the brand, the version of Android, the customization of the specific manufacturer. There are Android services, but there are also services introduced by the specific vendor. For every service, or at least for most of them, you can interact. This is, sorry, I skipped a couple of slides. This is a list of some of the most commonly found services running on an Android device. You can interact with those services. What does it mean? That you can request information to those services to get their state, to get an answer about their states, about what they are doing. I'm simplifying, but just to give you an idea. How can you interact with those services? There is a command that is available through an ADB shell that is called Dumpsys. Dumpsys is a tool that runs on Android devices and provides information about those about services. You can get the diagnostic output for all system services by simply running ADB shell Dumpsys without any other additional commands and other additional information in the command line. This is good, but it can be too huge, an enormous file, too difficult to interpret. So what I suggest to do is, I'm going to, the slide is a bit slower. Okay, oops, sorry. What I suggest you to do is, just one second, I lost the control of my presentation. Okay, perfect. So what you can do instead is running single commands, getting output from a single service. So ADB shell Dumpsys input, it will provide you the system data for input components, such as touchscreen and built-in keyboard. So you can get the specific service output by specifying the service name after the Dumpsys command. This is really useful, and of course it can be run in a script, and this is good to automate the process. This year, recently, a paper was published, and I strongly suggest you to read this paper. It's available on the CCD COE website, that is the NATO Cooperative Cyber Defense Center of Excellence. It's an interesting paper about using Dumpsys analysis to indicate driver destruction. And of course, what is described in this paper can be used for to find indication of driver destruction, but it can also be generalized to a more general approach. And I strongly suggest you to read it, especially because it describes the way in which dump services work, and also the advantages and the disadvantages. One of the disadvantages is that, of course, they are not designed for digital forensic purposes, and only a limited number of subject relevant system events are time-stamped, and those timestamps are not coherent. For example, some of them are in a specific time format, some of them are counted since the last boot, so you always need to take care in the interpretation of those data. But this paper is something that I strongly suggest you to read. A quick overview of some of the most interesting Dumpsys command that you can use. Dumpsys account will provide you a list of accounts. So basically you can see, for example, email address, WhatsApp accounts, Telegram accounts, the list of usernames used. It strongly depends by the specific application, but this is a kind of information that typically with a non-full file system or a non-physical acquisition, maybe it's more difficult to get. Some other examples, AppOps is really, really important. AppOps on the Android world AppOps are used for access control and tracking. What you can get for every single application the last time the application used a specific permission. So the last time an application used the permission of reading the external storage or writing the external storage. And this can be an indication of when the user did some specific actions. Other examples, battery stats. Battery stats is another key point. Battery stats allows you to understand which services, which processes were using the battery. And there is a tool called Battery Historian, and this is available. There is also on the developer.android.com website a guide on how to use Battery Historian. Battery Historian will allow you to understand who was using the battery, which service was using the battery. And this is really, really important, especially, for example, in malware analysis cases. Another example is the Bluetooth manager. Bluetooth manager, apart the Bluetooth information, that is something really important, it can be used for a specific purposes. If you run Dumpsys Bluetooth manager grep boot completed, basically you have the list of all the time the device was booted. So every time the device was turned on and booted is tracked in the Bluetooth log on an Android device. Can it be extracted? Can it be read in a full file system or physical acquisition? Yes. Is this information extracted with an advanced logical information? No, at least with the tool I tested, and I promise I tested most of the tools around. There is a recently published bachelor thesis by Nick Casier. Congrats, Nick. I've never met you, but this is a nice work. How to leverage Dumpsys to see and check interaction between an Android device and other Bluetooth devices. For example, sharing files from Bluetooth or connecting a device with another one. And this is another reading I suggest you to go through. CPU information. This is interesting. You can get the list of processes, how much CPU the process is using. You have references that I leave for additional reading. Database info. This is another key point. DB info allows you to get the list of all databases for all the packages. So also when you have an application in the data folder that you cannot extract the data from, you can get the list of databases and the creation time for every single database, modification time, and access time. You do not have the content, but still you can get the list of databases. And some of them, for some specific application, the name of the database contains an information in itself. Maybe the user ID of the user, or maybe the name of the contact or the phone number of the contact. Disk stats allow you to get the list, the disk usage statistics for system, cache, and data, and for every single application, photos, videos, audio, and download. And you can also run it in a way that allows you to get the per package stats. So the size of the application, so the APK, how much data is used by a specific application, how much cache is used by that specific application. This is another indication of maybe, you do not have access to the content, but you know that there are, let's say, 2 GB of Facebook cache or whatever it is. I'm going to go quickly. Notification. Notification is another important point. We get a lot of notification on our devices, on our Android devices, and maybe we read it, maybe not, but they are stored somewhere. And this is not, again, this is kind of information that is not extracted with the commonly available techniques, because you can just simply run Dumpsys notification, and if you add the no redact option, you will get the entire text of the notification. As you can see here, prenota esami diagnostici, it's in Italian, of course, but it's an email that was received. And also the other one is an email referencing to the YouTube access and modifying the terms of services of YouTube. So maybe you can get also list of notification from uninstalled application. And this is another interesting point. The package, Dumpsys package, allows you to get all the information about all packages, when a package was first installed, when was last updated, what is its data directory, where is the APK stored, and also which permissions were requested by the application at the install time, and which permissions are requested by the application at runtime, because you know now with recent version of Android you have install time and runtime permissions. Usage stats is the last one, or one of the last one. As you know, there is a great research by Alexis Brignoni on usage statistics on Android devices, and we currently know how to approach and how to parse usage statistics when we have a full file system or a physical image. Most of our tools support it, iLeap support it, but also most of our commercial tools support the parsing of usage stats. But when you have a device where you cannot get a physical or a full file system acquisition, you can rely on the operating system. You can ask the operating system to provide you the usage statistics. And here again, you can get information about specific application. You can see again here Tor browser that was moved to background or moved to foreground, or maybe an application was closed or whatever. So you can get a lot of information about various applications. This is also the number of time an application was launched in the last day, or in the last week, or in the last month, or in the last year. Vibration is another important point. Maybe you have a deleted call log, but from here you can get that the information that the vibrator was running, the phone was vibrating, and also the reason that caused the phone to vibrate. So a phone call was causing the phone to vibrate, and maybe you do not have the phone call at the same time. Dumpsys Wi-Fi allows you to get the list of all the Wi-Fi network, including when the phone was connected for the first time, and also depending on the buffer, but maybe you can, often you can get also more than one connection time. So the first one, but also different times in which the device was connected to a specific Wi-Fi network. You see here creation time and creation in milliseconds. You have the MAC address of the network. So a lot of things. You can also run a command in ADB called bug report. Bug report allows you to extract all the Dumpsys command plus other things. I suggest you to read this page on the Android website, on the android.com website, that explains you the internal structure of bug report and how to read it and how to get information from it. Third part, package manager. With package manager, you can get information about all the installed packages. An example is the list of users. In this case, it's not the list of accounts, but the list of Android user. Typically, it's only one, but we know that we can have devices with more than one user. So getting this list of users allows you to understand if you have only users 0 or maybe more users. PM list packages allows you to print all the packages, including their associated APKs. So getting the path to an APK is quite easy. Just simply run pm list packages.f. And with that, you can then use this command, the output of the package command, to extract the APK itself. Also, you can get the list of all permissions and which application is using which permission. And last, the ADB backup. The ADB backup is used by most of our tools. And we all know that it's a deprecated. So Android is going to remove it from the future version of ADB. But still, with modern devices, with recent devices, it works. The latest ADB version is still able to run an ADB backup, and you have to run it in a proper way. The best command is this one. And as you know, you can easily obtain an AB file. The AB file can be then converted to a TAR file and then can be opened, and you can get access to the content in an ADB. Be careful, as you know, an app will store that in an Android backup only if the flag allow backup in the APK is set to true. Last point for Android, pulling file. You can pull file from the device and store it in your computer, but you can only do it with the privileges of a non-root shell. So it means that you cannot get the data folder, but you can get the SD card that points to the emulated storage folder and typically contains media and other files. You can also get the system folder because this contains the operating system. Typically, it's not useful, but if you want to investigate, maybe it's a custom version of an operating system, or you want to investigate other things, you can also get the system. From the data partition, the data partition, and when it's mounted, the /data folder, you cannot get the file, the application file, but you can extract, of course, the APKs, because this is otherwise you are not able to either install, update, remove an application. And so getting the APK, especially for application installed from untrusted sources, can be a good point, for example, in malware analysis. And these are the commands that you can use to extract an APK. I automated all of this in a script that is freely available on our GitHub, and you can read the blog. It's from March. Now I have updated to version 1.1. I have a plan to update version 1.2 soon with a couple of more additional. But here you can run live commands, package manager, bug report, and so on. And this is how to run it. I still have 5 minutes, right, Heather? So I'm gonna go through. I'm on late, I know. I'm gonna go through iOS very quickly, because the advantage, or better, the disadvantage with iOS is that there are no native methods to interact with a shell. So you cannot open a shell on an iOS device, but you can interact at a sort of low level by using the Liby mobile device set of libraries. The Liby mobile device is an open source project that was also ported on Windows and allows you to extract various information. I'm going to show you some of the most interesting commands. One is these are the identification commands: iDevice name, the name of the device; iDevice ID, the UDID of the device; the iDevice date. It's useful to understand the timestamp and the time zone that is set on the device. By using iDevice info-q ComApple disk usage factory, you can get the list of amount available data, how much space is used by calendars, camera, media, and so on and so forth. The ComPurple Buddy service will tell you if the device was restored from an iTunes backup, from an iCloud backup, or if it is a freshly it's a device that was used freshly, so without reinstalling a backup. And also the ComApple mobile backup service that you can get with iDevice info-q ComApple mobile backup can tell you the last time the iTunes backup was executed. As you can see, there is a timestamp there, the time zone, and also requires encryption. If it is 0, it means that the backup password is not set on the device. If it is 1, it means that the backup password is required. All of this information can be easily extracted when you have a device that can be paired. We all know that our tools will prompt us to this information, but this is a low-level approach that can be useful. Also can be useful to extract the list of installed applications, either system or user. And with the user one, you can also get the detailed version, and the detailed version is really useful because from here, live from the device, you can get the path to the bundle and the UDID, sorry, the GUID of the data application, of the folder of the app in private var mobile containers data application and in shared. So we all know that it is one of the complex point, when you have to do a manual analysis of an app and which folder is used by that specific app, because we know that this part of the path changes in every single installation. So this is a quick way that we can use to get the list and mapping. There are various methods. Alexis and Yogesh Khatri you wrote great post on how to do it, but this is an approach that you can use on a live device. Last, sysdiagnose. We all love it. And Heather, along with Adrian Leong, we wrote a paper on it. The paper is still valid. It's from 2 years ago, but the technique is still valid. Why I suggest you, and why I wanted to add this point in my presentation of order of volatility, because generating a sysdiagnose is the best thing, thing that you can do on an iOS device when you still have the device turned on, if you want to get some live information. And in fact, if you generate it, and here you have a quick way on how to generate it, read the paper, please. You run then iDevice crash report by specifying the dash key, that means keep. So you are going to download crash logs and sysdiagnose from the device without removing it. And you can get this sysdiagnose file. Here you have the result, and this is our paper, and you have the result of the execution of live commands. It's like having an ADB shell, but it's not you running the commands, it's iOS deciding for you which commands are allowed or not. It's not a lot, but it's still something. You have PS, you have task info, and so on and so forth. With Liby mobile device, you can also create a full backup, like with iTunes, without the need of having iTunes.